Thank you everyone for coming today. My first time presenting at Embedded Vision, and to be honest, I spend a lot of time on vehicle level stuff and on automotive radar, so it's really good to get more exposure to Embedded Vision and how AI is working to unlock all these applications and functionalities. In fact, when I did my PhD and I was looking at thermal management of an electric vehicle, I had lots of different heat sources and I could control my heat pump to deliver as much heat to the cabin and battery as I wanted. And at one point I thought, can I use a neural network to try and optimize where to send the heat dependent on how long this journey is going to be, what the outside temperature is, things like that. And looking back now, having come to this conference, I realized how much I didn't know at that point and how far behind I was. So it's really incredible to see this technology and learn about what all you people are doing in more detail. So before I get into the talk, I just want a 2-minute introduction to IDTechEx. So we're a market research firm. We cover a wide range of technologies. So I focus on autonomous cars, sensors for cars like camera, radar, LiDAR. But we've got stuff from medical, from healthcare, across to things like 3D printing, AR, VR. A lot of industries that people at this conference are probably interested in for how they can get their AI technologies into these different applications. So in today's talk, we're going to be focusing on radar. So a lot of the data I present today, a lot of the research is coming from this report on automotive radar with forecasts from 2024 out to 2044. Over the course of today's presentation, I'm going to be talking about radar and how it's used in different industries, talking about performance requirements that are emerging from radar, particularly from automotive, which I think is probably one of the most demanding areas for radar. And then talking about next generation radars and sort of emerging radars today, how we're getting increased resolution, what 4-dimensional detection means, high dynamic range, which I think is an emerging characteristic that's kind of going to replace 4D imaging or come after 4D imaging. We'll then look at some of the packaging requirements in terms of the cost of the radar, the size of the radar, how much power it uses, and some trends related to, if you've got higher resolution radars, they're going to be using more power, and we'll see how much more power these radars are using. And then finally, we'll look at how these more powerful radars unlock new opportunities in terms of classification and how you might use radar data to improve object classification.